The AI-quaFarm project participates in the AI4Copernicus 5th Open Call. Aquaculture is expanding globally, with more than 87 million tons of fish being produced yearly. The production is expected to grow nearly 40% by 2030. Apart from the several benefits, the operation of fish farms generates significant number of waste components. Poor siting of fish farms is one of the main causes lead to impacts on the environment. In addition, selecting locations for new sites is a time-consuming and costly process. AI-quaFarm's goal is to use AI for selecting optimal locations for new aquaculture sites. This is the overview of the project's methodology. The project aims to utilize satellite images and the AI4Copernicus bootstrapping services. The first step is use of Sentinel-2 process service in order to transform the satellite images into products of common resolution for all the selected bands. After that, the generated images are passed through the Sentinel-2 harmonization service. The purpose of this service is to generate high-quality, consistent products. Then, the harmonized images are used to train a classification model. The purpose of this model is to analyze the characteristics and area that are used to decide if it is a suitable candidate for a new aquaculture site. For example, to identify the presence of existing aquaculture sites or urban environments. After the model is trained, it is then used to make predictions for a selected area and extract its characteristics. Finally, this output is combined with additional parameters that are used in the location assessment. The first step of the process is to collect the satellite images for the selected areas. We have selected two areas that already have plenty of aquaculture sites for training purposes: the Saggiata area and the Istokos area. The first service that is used is the Sentinel-2 processing service. This service receives as an input a Sentinel-2 image and a selection of bands. Then, it generates a TIFF image with a common resolution for these bands. We experimented with different band combinations that produced different results. We collected all the available Sentinel-2 images for the two selected locations for 4 months, and then, we passed them all through the processing service. The third step is the harmonization of the produced images. For this, we gathered for a specific band combination, all the image for a month. We then provided these images to the harmonization service, which generated the month composite images. These are high-quality images, without the noise coming from the clouds. The third step is to train the classification model. For this we had two goals. First, we wanted to identify existing aquaculture sites on the image. The second goal was to identify if the selected area is an urban or natural area, or if it has a beach. We then proceeded to the annotation of the available images. For this, we used an annotation tool and marked all the locations with an aquaculture site. We did the same with the locations that were urban, natural, or had a beach. Our focus was to annotate the coastline. Then, we used the month composites that were generated from the previous step, along with the image annotations, to train a deep network for pixel-level classification of Sentinel-2 patches. The output of this process was a trained classification model. We executed this process twice, for 2 different annotations. The next step was to use the trained model to make predictions. We fed the trained model with a new image and it performed the pixel-level classification, in order to identify the characteristics of the location. Finally, the goal was to integrate the predictions to the location evaluation process. The process starts with the selection of an area of interest. For this area, we gather the internal data about bathymetry, water temperature, water oxygen, port index, and more. Then, we fed the image of the area of interest into the classification model. If the model identifies the existence of aquacultures, urban environments, or beaches, we choose to reject the area.